Thrust and pressure. What is thrust? The force acting perpendicularly to a surface is called thrust. When you press a book on a table, you are exerting thrust there. The weight of objects on the surface, that's also thrust. The effect of thrust is decided by a physical quantity called pressure. So, can you define pressure? Pressure is the thrust per unit area, which will give you a mathematical expression. P is equal to F by A. So, here F is the thrust and A is the area on which it is acting. From the expression, what is the SI unit? The SI unit is Newton per meter square. We also call it Pascal. So, define 1 Pascal. 1 Pascal is the pressure exerted by 1 Newton force on 1 meter square area. So, from the expression itself, it is clear that area has some role here. Area is in the denominator, which means as area increases, pressure decreases, and as area decreases, pressure increases. So, we can say it as smaller the area, more pressure, larger the area, less pressure. We know that a sharp knife is easy to use. This is because of the less area of contact. So, we know the ends of nails and pins, they are also pointed. This is to make sure that the pressure produced is more there. So, you can cite so many examples like that. One of the features or peculiarity of pressure is that it is not limited to solid surfaces. Fluids can also exert what? Pressure. When a liquid or gas is taken inside a container, they are having the ability to flow and they have its own weight. So, when taken inside a container, for example, a liquid, it is exerting a pressure on the walls as well as on the bottom. You can see the example here. I have taken some liquid inside this container and what is the density of the liquid? It is rho. Now, let us see the features of liquid pressure. The first one is pressure increases with the depth, that is P proportional to H. What does this mean? We have 4 points here, A, B, C, D. As depth increases, what is going to increase? The height of the liquid column above the point. As the height of the liquid column increases, the weight above the point increases. This will increase what? Pressure acting on that particular area. That is P proportional to H. And what's the second point? Depends on density of liquid, that is P proportional to rho. Different densities are exerting different pressure. Third point is, it depends on acceleration due to gravity G, that is P proportional to G. So, these dependence will give you an expression, that is P is equal to H rho G, where H is the height of the liquid column, rho is the density of the liquid and G is the acceleration due to gravity. Other important feature is that at same depth, the pressure will be same. For example, we can see C and D here. These points are at same level or same depth. What is pressure at C and what is pressure at D? Pressure at C is equal to pressure at D. This is because the height of the liquid column above C and height of the liquid column above D is same. So, the pressure exerted on the points at the same level are also equal. And one important thing is, acts in all directions. The pressure exerted by the liquid is acting in all direction, which means this liquid is exerting pressure on the walls and on the bottom. But the pressure exerted by the liquid itself on the surface, that is at the point A, what will be the pressure there? It will be 0 because above A there is no liquid. So, there is no pressure exerted by the liquid at A or on the surface. And the last point is, it is independent of shape and size of the container. It does not depend on the size or shape of the container. That is all about the liquid pressure and these are the features.